In this lesson, you will learn to multiply complex numbers. A complex number is in the form a plus bi, where a is the real part and the bi is the imaginary part. An imaginary number is defined by I equals the square root of -1. If we square both sides, we get I squared equals the square root of -1 squared. Well, squaring and square root cancel one another because they are opposite operations, so it leaves us with I squared equals -1. So it is good to know that I equals the square root of -1 and I squared equals -1. Let's look at our examples. We're going to find the product of 4 plus 9i with 6 minus 2i. So in order to multiply these complex numbers, we will use the distributive property. We're going to multiply the 4 with the 6 minus 2i, and then we're also going to multiply the 9i with the 6 minus 2i, distributing each term from the first parentheses to both terms in the second parentheses. So set up your problem to distribute. So now we will multiply. 4 times 6 is 24. 4 times -2i is -8i. 9i times 6 is 54i. And 9i times -2i is -18i squared. Notice that the I acts just like a variable. When we multiply, we treat it like a variable, like any other problem when you multiply. Here's where you will need to apply what we've learned about I squared. I squared equals -1. So therefore, we will replace I squared with this -1 and multiply -18 times -1, leaving us with plus 18. So bring down the first 3 terms of the problem. We have the 24 minus 8i plus 54i. We're going to have that plus 18 now. Because I squared equals -1, you replace the I squared with that -1 and then multiply with the coefficient that you had with the I squared. So negative times negative makes that a plus 18. So our final step is to write our answer as a complex number. So we'll need to combine the real parts and the imaginary parts. So 24 plus 18 gives us 42. And -8 plus 54, -8i plus 54i gives us 46i. Be sure to write your answer in this form for a complex number, a plus bi. Let's look at example number 2. So we have -3 plus 12i. We're going to multiply with 7 plus 4i. So set up your distributive property. We have -3 times the second parentheses, 7 plus 4i. And 12i times the second parentheses, 7 plus 4i. Distribute in order to get your terms. So we get -21, -12i, positive 84i, and positive 48i squared. I times I will give us I squared. So now recall I squared equals -1. So replace your I squared with that -1. And remember, you are multiplying here. Do not subtract 1 from 48. This is not subtraction, it is multiplication. So that's going to become a -48 or a -48. Bring down the first 3 terms of your problem. So we have negative 21 minus 12i plus 84i, and now the minus 48. Because of I squared equaling negative 1, we replace the I squared with the negative 1 and multiply that with the coefficient you had on the I squared term. Positive times negative makes this now a negative 48. So we'll write our answers as a complex number, a plus bi. So we'll need to combine our real parts, so negative 21 minus 48, and our imaginary part, negative 12i plus 84i. So our answer is negative 69 plus 72i. Let's look now at example number 3. We have 6 minus 5i. We're going to multiply that with 3 minus 10i. Feel free to pause the video and try this one on your own. We'll set up the distributive property, 6 times 3 minus 10i, and negative 5i times the 3 minus 10i. Distribute to get each term. We have 18 minus 60i minus 15i plus 50i squared. As always, be very careful with your signs. We have I squared that equals negative 1, so we'll replace the I squared. 50 times 1, or 50 times negative 1 gives us negative 50, and bring down the first 3 terms. To write our answer as a complex number, a plus bi, we'll need to combine the real parts and the imaginary parts. So we have negative 32 minus 75i. Let's look at this final example. Electrical engineers use complex numbers when analyzing electric circuits. Find the voltage of a component of an electric circuit by squaring the binomial 8 minus I quantity squared. Recall that squaring means times itself. We will not square the 8 and square the I. That does not work when there's a plus or a minus sign with that exponent. You must write it out twice and distribute. Squaring means times itself. So we'll use the distributive property here. So we have 8 times the 8 minus I, and then negative I times the 8 minus I. We'll distribute 8 times 8, 8 times negative I times 8, and negative I times negative I. Here notice we have I squared equaling negative 1. I do recommend that you put the coefficient in front there. It is a 1, so that when you're replacing I squared as a negative 1, you know you're really going to take 1 times negative 1. So that is going to make it a minus 1, which is the definition of I squared, being negative 1. Bring down the first 3 terms and we'll combine our like terms. 64 minus 1 is 63. And negative 8i minus 8i gives us negative 16i.